Hello, fellow physics educators. Welcome to another episode of Physics Bites, the blog where we break down complex physics concepts into digestible bites. In our latest episode, please join our team members, Teacher Jet, Teacher Mar, Teacher Christine, and yours truly, Teacher Hazel, as we unravel the mysteries of thermodynamics through the lens of statistical mechanics. Get ready for a mind-expanding journey into the microscopic world that governs the macroscopic behavior of the universe. Let's dive into the fascinating realm where physics meets statistical intricacies. Take it away, teachers.
Thank you, Ma'am Hazel. Indeed, teachers are amazing. How are you, my dear physics teachers? I am very happy that you are with us again as we give you some important ideas on how to teach special topics on classical statistical mechanics, particularly thermodynamics. I am definitely sure that everyone will not agree if I will say thermodynamics is a funny subject. Let me share the famous quote of Arnold Sommerfeld. Arnold Sommerfeld is a German theoretical physicist who pioneered developments in atomic and quantum physics. And he said, thermodynamics is a funny subject. When time you go through it, you don't understand it at all. The second time you go through it, you think you understand it, except for one or two small points. The third time you go through it, you know you don't understand it. But by the time you are so used to it, it doesn't bother you anymore. To make it more amiable to our learners, you may initially introduce the concept of thermodynamics by its nature and background. This will lead into understanding of bits and pieces of thermodynamics. To support this idea, you may also start by posting questions that will serve as the starting point of discussion. You may also support the discussion of thermodynamics by using deductive reasoning, where it will start from general down to concrete context. You may also do this by supporting the discussion with hands-on experiment or hands-on demonstration to make it more realistic. At the same time, it will also be appreciated by our learners. Since our learners are fond of visual lessons, you need to ensure that your video is an interesting video, enabled for you to catch the interest of your students. I have an example here. During your free time, you can also check this sample video to uplift your discussion about thermodynamics. And since the main friend of our learners is their phone, you may also integrate the connection of statistical mechanics to thermodynamics by using apps in the discussion like Thermodynamics Formula Memorizer, Thermodynamics Calculator, and physics questions. So while they are using their personal devices, you are also maximizing your learnings through this. Thank you very much for listening, and may I now call Ma'am Chris to share the other inputs. Ma'am Chris, take it away.
Thank you so much, Sir Mar, for those very insightful discussions. I know teaching thermodynamics could be a bit challenging, but we are here to explore practical, engaging, and effective teaching methods in teaching our students thermodynamics. Let's break it down into manageable pieces for our students. Statistical mechanics help us connect the microscopic behavior of individual particles to macroscopic observations. Think of it as predicting the future in a tiny scale. How can we make this accessible to our students? Consider using everyday examples like a deck of cards to explain microstates and macrostates. Connect these concepts to gas particles in a container or the fluid inside the refrigerator. The average behavior of molecules connect with the macroscopic properties such as temperature and pressure. Entropy is linked to the number of microstates. More microstates means higher entropy, representing more ways for particles to be arranged to produce the same macroscopic result. This way, we are not teaching, but we are making it relatable and easy to grasp. Engagement is the key. And what better way to keep it involved than through challenges and quizzes? We can create interactive quizzes with platforms like ClassPoint, Mentimeter, and Canva. You can use this to create your own test to your students, to test your own students' understanding in a fun and creative way. And for challenges and problem solving, imagine turning your classroom into a thermodynamics escape room. Design puzzles related to real-world scenarios where students must apply thermodynamic principles to solve them. This not only reinforces learning, but also adds an element of excitement.
Teaching thermodynamics doesn't have to be daunting. By connecting it to everyday life, by simplifying complex concepts, and incorporating engaging challenges and quizzes, we can make it a rewarding and memorable experience for our students. This time, I'm going to hand over to Sir Jet for the real-world problem-solving applications. Sir Jet?
Thank you, Ma'am Chris, for your discussion on thermodynamics in everyday life. Now, on this part of the video, we're now going to show thermodynamics in action. In particular, we're going to demonstrate how to use real-life scenarios to teach thermodynamic concepts and to provide guidance and asking the right questions to stimulate student thought and application. We may begin with a familiar morning scene, a steaming cup of coffee. As it cools, we see a live demonstration of heat transfer and thermal equilibrium. The coffee loses heat to the environment until the thermal energy is uniform, illustrating zeroth law of thermodynamics in a practical setting. You might want to ask your kids when you're discussing this with them, why does coffee cool faster on a metal table compared to a wooden one? Of course, we know that's on specific heat capacity and conductivity, okay? You encourage your students to delve into the principles of conductivity and specific heat, which are crucial into our understanding of energy dynamics. Another practical and simple scenario that you can ask in teaching thermodynamics is visualize an ice cream cone melting on a sunny day. This isn't just about dessert. It's phase change in action. The ice cream absorbs heat without changing temperature until it shifts phase. And this is an engaging way to discuss the first law of thermodynamics and the conservation of energy. You might want to challenge your students. What factors affect the rate at which the ice cream melts? So there are many factors, right? Can you discuss one in the comments below? Show us that you know it. Okay, next. Another one is the marvel of thermodynamics, the refrigerator right in our kitchen. So let's examine our humble refrigerator. It demonstrates the second law of thermodynamics, that heat naturally flows from warmer to cooler places. Understanding the fridge's cycle of expansion and compression sheds light to entropy increase and energy efficiency. Encourage your students, encourage curiosity by asking, how does the refrigeration cycle conserve energy while moving heat? This can lead to an insightful discussion of the Clausius statement of the second law and the practical application of heat engines. Now that you're done with the basics, so you see, from coffee to ice cream to simple refrigerator, you can now dive deeper with Stirling heat engine. It's a prime example of thermodynamic cycle. As physics teachers, we know that, okay? The Stirling engine works by compressing and expanding a gas in a continuous cycle. This cycle includes extracting heat and then performing work and then disposing of unused heat and repeat the process, okay? You can actually ask your students to create their own GeoGebra program or simulation to simulate what is happening with the Stirling engine. However, you can also have another. If you have the Stirling kit, you can also have this one. It's a 2-minute-ish video. I'm sorry, time constraint, I cannot provide you, but I'll be putting the link in the I cannot play it, but I'll be putting the link in the description box, okay? And we know, truth be told, sometimes materials are still to be made available in the Philippines. So as teachers, we need to improvise, right? So here is an idea: simulating Stirling heat engine using basic materials, a balloon, 2 small jars or cans, a wire or rigid straw to connect the balloon to the jars, and hot and cold water, okay? And then here is here are the steps. You can pause the video, take a screenshot of it, and then try. And then you let us know whether it works or not, okay? Now, a disclaimer in here is that this simple model demonstrates the basic principle of the Stirling engine, where heat energy is converted into mechanical energy by the expansion and contraction of air or another gas at different temperatures. However, from classroom to the global context, you can even ask your students great questions, because we believe in Physics Bites, we believe that great teaching thrives on asking the right questions. You can challenge your students to design their own eco-friendly cooler. In here, they're going to think critically and they're going to apply their knowledge. How can they use thermodynamics to solve real-world problems? Like in this particular example, it's a practical application of their learning. Or if you want to practice international mindedness, you can discuss heat engines and their impact on CO2 emissions. You can ask the question, are there substitutes for heat engines? Or how effective is replacing fuel engines with electric motors in reducing CO2 emissions? These discussions can lead to meaningful insights about sustainability and the role of physics in addressing global challenges. As teachers, I encourage you to reflect on these strategies. How can they be woven into your teaching style? Remember, we're not just teaching physics, we're unraveling a fascinating story that unfolds every day around us. Okay, so we're almost at the end of our vlog, and what have we been doing? So here is a summary. We looked into the core concepts of thermodynamics, like your entropy, your heat engine, energy transfer, work, laws of thermodynamics. And then we presented some strategies for you to adapt the think framework, the practical applications, even the employment of the Socratic method. And we provided some ways on how you can challenge your students to think critically by asking the right questions, by doing effective assessment, and even practicing international mindedness. Okay, so finally, we have all of these things from us, and I hope you enjoyed our video. And that's a wrap on our thermodynamics journey. Thank you for joining Physics Bites. Till next time, where we digest physics knowledge one bite at a time. Bye!